Hi! Today, we will learn about quadratic inequalities in two variables. There are quadratic inequalities that involve two variables. These inequalities can be written in any of the following forms. Y is greater than ax squared plus bx plus c. Y is greater than or equal to ax squared plus bx plus c. Y is less than ax squared plus bx plus c, and y is less than or equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Some examples are y is less than x squared plus 3x plus 2, y is greater than 2x squared minus 5x plus 1, y plus 9 is greater than or equal to negative 4x squared, y minus 7x is less than or equal to 2x squared. So how do we solve quadratic inequalities in two variables? The solution set of quadratic inequalities in two variables can be determined graphically. In order to do this, follow these steps. For step 1, write the inequality as an equation. Step 2, construct a table of values for x and y. Plot and connect the points in the Cartesian plane. A broken line is used in connecting the points when the inequality symbol used is greater than or less than, while a solid line is used when the inequality symbol is greater than or equal to or less than or equal to. Step 3. Choose a point in each region and check whether the given inequality is satisfied. And for the last step, shade the entire region that satisfies the given inequality. Let's now have an example. Find the solution set of y is greater than x squared minus 2x minus 1. So for step 1, we will write the inequality as an equation. So it becomes y is equal to x squared minus 2x minus 1. Step 2, construct a table of values for x and y. Plot the points in the Cartesian plane and connect. So given the values of x, we will solve for y using the given equation. Let x be equal to negative 2. So we will substitute negative 2 in the equation y is equal to x squared minus 2x minus 1. So we have negative 2 raised to the second power minus 2 times negative 2 minus 1. Negative 2 squared is 4. Negative 2 times negative 2 is positive 4 minus 1. 4 plus 4 is 8. 8 minus 1 is equal to 7. So when x is negative 2, y is equal to 7. So let's write it in our table of values. Next, let x be negative 1. Substitute negative 1 in the given equation y is equal to x squared minus 2x minus 1. Negative 1 squared minus 2 times negative 1 minus 1. Negative 1 squared is 1. Negative 2 times negative 1 is positive 2 minus 1. 1 plus 2 is equal to 3, and 3 minus 1 is equal to 2. So when x is negative 1, the value of y is positive 2. Next, let x be equal to 0. Substitute 0 in the equation y is equal to x squared minus 2x minus 1. So we have 0 squared minus 2 times 0 minus 1. 0 minus 0 minus 1. that will be negative 1. So when x is 0, y is equal to negative 1. Next, x is equal to 1. Let x be equal to 1. Substitute 1 as a value of x in the equation y is equal to x squared minus 2x minus 1. So we have 1 squared minus 2 times 1 minus 1. 1 squared is 1. Negative 2 times 1 is negative 2 minus 1. 1 minus 2 is negative 1 minus 1. That will give us negative 2. So when x is positive 1, y is equal to negative 2. Next, if x is equal to 2, so let x be equal to 2. So we have y is equal to 2 squared minus 2 times 2 minus 1. We have 4 minus 4 minus 1. 4 minus 4 is 0, minus 1, that will give us negative 1. So when x is 2, y is equal to negative 1. Next, let x be equal to positive 3. So the given equation is y is equal to x squared minus 2x minus 1. Substitute 3 as a value for x. So we have 3 squared minus 2 times 3 minus 1. That will give us 9 minus 6 minus 1. And that is 9 minus 6 is 3. 3 minus 1 is equal to 2. So when x is positive 3, y is equal to 2. And for the last one, we have x is equal to 4. So let x be equal to 4. Again, using the equation y is equal to x squared minus 2x minus 1, substitute 4 to x. So we have 4 squared minus 2 times 4 minus 1. So we have 16 minus 8 minus 1. That will give us 16 minus 8 is 8 minus 1, 7. So when x is equal to 4, y is equal to 7. So we now have our table of values. So here now is our table of values. That our next step is we will plot the given points in the Cartesian plane. Okay, so the first point we have negative 2, positive 7. Next point we have negative 1, positive 2. Next point we have 0, negative 1. Next point we have 1, negative 2. Next point we have 2, negative 1. Next point we have positive 3, positive 2. And then for the last one, we have 4, 7. After that, we will connect the points. Since the inequality symbol used is greater than, therefore a broken line will be used in outlining the parabola. Next, step 3, choose a point in each region and check whether the given inequality is satisfied. Okay, first we will choose a test point inside the parabola. So inside the parabola, let's say we have the test point 1, 1, this point. So we will use it as a test point. We have the inequality y is greater than x squared minus 2x minus 1. So let us substitute 1 for x and 1 for y. One squared is 1. Negative 2 times 1 is negative 2 minus 1. 1 is greater than 1 minus 2 is negative 1 minus 1. 1 is greater than negative 1 minus 1 is equal to negative 2. 1 is greater than negative 2. It is a true statement or a false statement. This is a true statement. Let's have another test point, but this time outside the parabola. So you can choose any point outside the parabola. Let's say we choose 5, 0. This is outside the parabola. So our test point is at 5, 0. So in the given inequality y is greater than x squared minus 2x minus 1, we will substitute 5 for x and 0 for y. 0 is greater than 5 squared minus 2 times 5 minus 1. 0 is greater than 25 minus 10 minus 1. 0 is greater than 25 minus 10 is 15. 15 minus 1 is 14. So the statement is 0 is greater than 14. Is it a true statement or a false statement? This is a false statement since 0 is less than 14. So since the test point inside the parabola we made a true statement, it only means that the region that satisfies the given inequality is inside the parabola. So what we're going to do is we will shade the entire region inside the parabola. Okay, let's shade. This region inside the parabola. It means that the points here satisfy the given inequality. So with that, we can say that all the points in the shaded region make up the solution set of the inequality y is greater than x squared minus x minus 1. Let's have another one. Find the solution set of y is less than or equal to 2x squared minus 3x plus 1. So step 1, write the inequality as an equation. It now becomes y is equal to 2x squared minus 3x plus 1. Step 2, construct a table of values for x and y and plot the points in the Cartesian plane and connect. So for a table of values, we will assign values for x and then we will solve for the values of y using the given equation. Using y is equal to 2x squared minus 3x plus 1. So let x be, let's have the first one, negative 1. So if x is negative 1, what is the value of x? What is the value of y? So we have 2 times negative 1 squared minus 3 times negative 1 plus 1. 2 times 1 plus 3 plus 1. So we have 2 plus 3 plus 1, that is 6. So if x is negative 1, y is equal to 6. Next, let x be equal to 0. Using the equation y is equal to 2x squared minus 3x plus 1, let us substitute 0. 2 times 0 squared minus 3 times 0 plus 1. This is now equal to 0 minus 0 plus 1, and that is equal to 1. So if x is 0, y is equal to 1. Next, let x be equal to 1. We have y is equal to 2x squared minus 3x plus 1. Substitute 1 to x. So we have 2 times 1 minus 3 plus 1. That is 2 minus 3 plus 1. 2 minus 3 is negative 1. Negative 1 plus 1, that is equal to 0. So if x is 1, y is equal to 0. Next, let x be equal to 2. So we have 2 times 2 squared minus 3 times 2 plus 1. 2 times 4 minus 6 plus 1. 8 minus 6 plus 1. 8 minus 6 is 2 plus 1, that is equal to 3. So if x is 2, y is equal to 3. Next, let x be equal to 3. We have 2 times 3 squared minus 3 times 3 plus 1. 2 times 9 minus 9 plus 1. So we have 18 minus 9 plus 1. 18 minus 9 is equal to 9. 9 plus 1, that will be 10. So if x is 3, y is equal to 10. That now is our table of values. Now using the table of values, we will plot the given points in our Cartesian plane. So for our first ordered pair, we have negative 1, 6. Negative 1, 6 is located here. Next ordered pair, we have 0, 1. It's located here. Next, we have 1, 0. And then we have 2, 3. And then for the last ordered pair, we have 3, 10. Next thing that we're going to do is we will connect the given points. Since the inequality symbol is less than or equal to, therefore a solid line will be used in outlining the parabola. We will no longer use A, so we will not use broken line here, since the symbol is less than or equal to. Next step is we will choose a point in each region and check whether the given inequality is satisfied. So let us first choose a test point inside the parabola. Any point inside the parabola. So let's say we have point 1, 5. So 0.15 is located inside the parabola. Using the inequality, y is less than or equal to 2x squared minus 3x plus 1. We will substitute 1 for x and then 5 for y. So we have 5 is less than or equal to 2 times the value of x is 1 minus 3 times 1 plus 1. 5 is less than or equal to 2 times 1 minus 3 plus 1. 5 is less than or equal to 2 minus 3 plus 1. 5 is less than or equal to 2 minus 3 is negative 1. Negative 1 plus 1, that is 0. So the statement now is 5 is less than or equal to 0. The question is it a true statement or is it a false statement? 5 is less than or equal to 0. This is now a false statement, since 5 is not less than or equal to 0. Next, let us choose a test point, this time outside the parabola. Any point outside the parabola. Say for example, we have point 0, 0. It is located outside the parabola. So we will substitute 0 for x and 0 also for y. In the inequality, y is less than or equal to 2x squared minus 3x plus 1. 0 is less than or equal to 2 times 0 squared minus 3 times 0 plus 1. 0 is less than or equal to 0 minus 0 plus 1. 0 is less than or equal to 0 minus 0 is 0 plus 1, 1. The statement now is 0 is less than or equal to 1. Is it a true statement or a false statement? It is a true statement, since 0 is less than 1. So it only means that the solution set are the points outside the parabola. So we will now shade the entire region that satisfies the given inequality, and that is outside the parabola. So let us shade. With that, we can say that all points in the shaded region, including those along the solid line of the parabola, make the solution set of the inequality y is less than or equal to 2x squared minus 3x plus 1. So that is how we solve quadratic inequalities in two variables graphically. Thank you very much.